This is the story of a boy named Jimmy who got accepted to McMaster University's social science program. As you can see, he's pretty excited about this, but unfortunately, these are Jimmy's parents who can't afford to help him pay for school. So Jimmy has to apply to OSAP. Four years later, Jimmy graduates from Mac. And whereas this should be a happy time for him, Jimmy is sad, because now he's several $1,000s in debt. What Jimmy realizes, though, is that this is part of a bigger issue, as he is one of many graduates who are stuck paying back their unreasonable amounts of student debt. We know that this large student population has the ability to drastically affect the way Canadian politics works. So, our question is, how does student debt affect political participation in Canada? So, keeping our research question in mind, Jimmy hypothesizes that the higher the amount of student debt is, the more political unrest there is amongst his demographic. But, my fellow students, just how much debt are we talking about? To test this research question, Jimmy has decided to use the confidence interval, which is an estimate of a population value in which a range of value is specified. By using the confidence interval over the long run, research is willing to be wrong only 5% of the time. Additionally, this should show us the range of the amount of debt the average Canadian student with debt has. As mentioned, we will be using the confidence interval, specifically of the sample mean, to find out the statistics we want to know. The equation, CI equals x bar plus or minus z times the standard deviation over the square root of n minus 1, means that we have to find our mean, x bar, the z-score of our alpha, which represents the percentage of error we're allowing, as well as the standard deviation and the standard error, n minus 1. Moving on, we have our data set of 100 selected students representing the amount of debt that they each hold. We must calculate the standard deviation using the equation we know with our average of $35,978.33, our n of 100. We get a standard deviation of $11,897. Next, finding the z-score for our selected alpha is relatively simple. The chart on page 154 will give you the z-scores for the four most commonly used alphas. We selected a 5% alpha, for which the z-score, found in the back of the textbook, is plus or minus 1.96. At this point, we're ready to complete our confidence interval long-handedly. The equation will look as such: CI equals x bar, or $35,978.33, plus or minus our alpha, 1.96, times our standard deviation, 11,897, over our standard error, square root, n minus 1, or 100 minus 1. Because this is a sample of the larger population, we must use n minus 1 as our standard error to account for the bias in the standard deviation of which we had to calculate. If the standard deviation had been given to us, it would simply be the square root of n. Now, using our skills as social science mathematicians, we can plug in these numbers and compute our final confidence interval. We end up with CI equals $35,978.33 plus or minus $2,343.52. This gives us a high of $38,321.85 and a low of $33,634.81. Now that we've
Once
done
your
this
data set is
longhand,
inputted into
it's time to show
SPSS,
you how to do
we are
this
ready to
process
begin.
using SPSS. Additionally, we'll be using the explore function as it has more available features than the frequencies and descriptives functions as previously used. From the main menu, click Analyze, Descriptive Statistics, and Explore. The Explore dialog box will open up. Use the cursor to select the dataset that you wish to use, and the right arrow button to transfer the variable to the dependent list box. SPSS, by default, uses the 95% confidence interval, which in fact we want to use for this demonstration. To request another level, you can click on the Statistics button at the top of the Explore dialog box, and the Explore Statistics dialog box will open. Type the desired confidence level, example 90%, 95%, 99%, in the text box next to confidence interval for mean and click Continue. You will return to the Explore dialog box where you might want to click the Statistics Radio button within the Display section. Otherwise, SPSS will produce both summary statistics and plots. Finally, click OK and the output below will be produced. From this table, we're given statistics such as our mean, our 95% confidence interval for our mean, as well as the lower and uppers of it, 5% trimmed mean, median, variance, standard deviation, our min, our max, our range, our interquartile range, and our skewness, as well as our standard error. What we want to do now is to calculate an error bar graph, which is simply a visual representation of our mean as well as our uppers and lowers in our confidence interval. To do this, we will click Graphs, Legacy Dialogs, and then Error Bar. The Error Bar's dialog box appears with two choices for the type of graph we want. The simple option is already highlighted, and this is the one we want. At the bottom of the Error Bar's dialog box, click the Summaries of Separate Variables radio button within the Data Chart box, and then click Define. The Define Simple Error Bar dialog box appears with variable names listed on the left. Use the cursor to find our variable in the list on the left and click the right arrow button to transfer the variable to the Error Bars box. In the Bars Represent box, you have the option to select whether the error bar represents the confidence interval of the mean, the standard error of the mean, or the standard deviation. Let's choose confidence interval for the mean, the option that is already selected. You can also enter the desired confidence level into the level box. We'll use a 95% level, which is the default setting. Click OK, and this will be produced. And there you have it, our confidence interval with our error bar graph, complete. Jimmy's data shows us a couple different things. The main thing we can glean from all this is that average student debt is relatively high. Unfortunately, there are also some limitations to this research question. It fails to show us the potential that each of these students has to pay off their student debt. Additionally, it also fails to show us which of these students has a job potentially lined up for when they graduate. As well, comparing this data to different generations of students would likely be different. Students have increased over time, as well as the number of international students has increased over time. This could also be an issue if tuition has simply gone up more than the amount of students has gone up.
I just have no idea how I'm gonna pay for my tuition.
Great catch, son. How would you like to be my new starting wide receiver on full scholarship?
I've always loved you, Jenny! I love you too!
School isn't like the movies. Real students could use a little help. Eligible full-time students could get 30% off an average college or university tuition. Apply now.
Below the 30% tuition grant is a new policy. Ontario's PCs are trying to take it away because they argue that those who need it don't qualify to begin with. The system is failing our students with loans. We can also assume that Jimmy found a correlation with student debt and political participation. Looking at these numbers and comparing it to the general unrest that we see in Canada's provinces, looking at you, Quebec, political unrest is rising among disgruntled students. Financial burdens are likely to steer some students away from getting an education. This could sour their moods toward politics and cause different levels of political activism amongst them. The influence on political participation is vital to student socialization. Student activism is reliant on politics. However, the debt of students and their education influences political opinion.